Chapter 5 starts with midsegments and triangles. In Chapter 5, we'll actually continue working with triangles, and instead of proving they're congruent as often as we have in Chapter 4, we're going to start looking at some different properties and postulates and theorems about some of the characteristics of triangles that we can use as we continue to work with them. So a midsegment, now this is the general definition for a midsegment, not specific to a triangle. Midsegment in any shape is a segment that connects the midpoints, of two sides. So within every triangle, there are going to be 3 midsegments. What I'd like you to do real quickly is draw a triangle on your paper. And then once you have a triangle, just eyeballing, you don't have to measure, you don't have to actually construct these. Need you to draw in your midsegments. So here's a random triangle that I chose to draw, and if I draw in my 3 midsegments, I would have this picture. Now, in order to tell that these are actually midsegments, we need a few more markings, because if these are connecting midpoints of the sides, I need to know somehow that these points where these midsegments are connecting are actually the midpoints of those sides. And one way to show that is by showing that each of those points is splitting the side of the larger triangle into 2 congruent halves. So now, specific to triangles, we have the triangle midsegment theorem. And this tells us that if a segment joins the midpoints of 2 sides of a triangle, so basically if you have a midsegment in a triangle, that segment, so that midsegment is parallel to the third side, and it is half the length of that third side. So if we're given in our diagram that segment DE is a midsegment of triangle ABC, okay, we could also be shown that visually in the diagram by knowing we have the congruent parts as I've just drawn in. We would be able to make a couple of conclusions using this theorem. We would first be able to say that segment AB is parallel to segment DE, so that midsegment is parallel to that third side. And also, we would be able to say that the length of DE is half the length of AB, or just using a little bit of algebra, multiplying both sides by 2, we'd be able to say that AB is 2 times the length of DE. These come from the same idea of the midsegment being half of the length of that third side. 2 different ways of writing it. One might be more useful than the other, depending on what information you have, what type of problem you're doing. So what we're going to do now is we're going to actually prove the triangle midsegment theorem. But we're going to do this differently than we have in the past. We're not doing a 2-column proof here. So as I go through this, I'd like you to follow along and write down what I show you. So we're given that R is the midpoint of segment OP. We're given that S is the midpoint of segment QP in this triangle OPQ that we have a graph of. Our job, if we're proving the triangle midsegment theorem, is to prove the 2 parts of the triangle midsegment theorem. We have to prove that the midsegment is parallel to the third side, and we have to prove that the length of the midsegment is half the length of that third side as well. So I've got 3 steps to the process here that I'm going to use. This process is not always going to be the same for types of proofs that you're going to do like this, but this is something that you may want to consider doing, maybe writing out the steps or the things that you need to do in order to be able to prove what it is you need to prove. So the first thing that I'm going to take care of is if I have to figure out that I have parallel lines and I have to talk about lengths of those lines, I need to know what points I'm dealing with. So the first thing I'm going to do is I'm going to find the coordinates of R and S. And I'm given that those 2 points are the midpoints of their respective sides, so I'm going to use the midpoint formula to accomplish this. So the midpoint formula, we need to first be able to recall or look up. Okay, you have to be in the habit of looking things up when you don't remember them. So the midpoint formula You take the x coordinates of 2 points, you add them together and divide by 2, and you take the y coordinates of 2 points, add them together, and divide by 2. So if I'm going to find the coordinates of point R, I need to use the 2 points, the 2 endpoints of this segment, plugging into the midpoint formula. So I would be able to take b plus 0 over 2 and c plus 0 over 2. Then if I simplify that as much as I can, my coordinates for point R are b over 2 and c over 2. Do the same type of thing for S. The points I have to use to find the coordinates of S are P and Q, the endpoints of that segment. So I would be taking A plus B over 2 for my X values and 0 plus C over 2 for my Y values. Simplifying a little bit, I can make that Y coordinate C over 2. A plus B over 2, I can't do any simplifying with. I have to leave it as is. So now that we have those two ordered pairs for the two midpoints, R and S, or the endpoints of our midsegment, next thing we can do is prove that we have the midsegment parallel to the third side. Now, if you think about it, how do you prove lines are parallel? What have we talked about looking at? We have to show that they have equal slopes. In order to prove they're parallel, we have to show slopes would be the same. Well, that means that we need to first recall the formula to find slope. That is y2 minus y1 over x2 minus x1. So it doesn't matter which one you do first. Let's say I'm going to find the slope of segment RS first. I need to take the coordinates that I just found in the first step and plug them into this formula. So c over 2 minus c over 2 all over a plus b over 2 minus b over 2. So in the numerator, c over 2 minus c over 2 would be 0. In the denominator, I would be able to simplify that to a over 2. And then 0 divided by a over 2, or really 0 divided by anything, is 0. So we know the slope of segment RS equals 0. Now I have to find the slope of segment OQ. So if I plug those coordinates into the slope formula, I have 0 minus 0 over a minus 0. So 0 over a is still 0. Since these are the same, we can make a conclusion. So in math, we have this symbol that's 3 dots in this triangle. It stands for the word therefore. So basically, it signifies that you're making a conclusion. Since we have these equal slopes, therefore we can say that segment RS is parallel to segment OQ. And we've actually proven the first part of the triangle midsegment theorem. The last thing we have to do is we have to show that the length of RS is equal to half the length of OQ. And if we're talking about length and we have points on a graph, the way that we find length is distance formula. So the distance formula we have to recall or look up and find that it is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So now I have to do this twice. I have to do it once for the length of RS and once for the length of OQ. It does not matter which one you do first. I chose to do the length of RS first. Notice I have RS equals with no line over the top. So this is telling me that this length is the length of segment RS. Don't put a D here. Be specific about which segment length this is. It keeps your work more organized. It makes it easier for me to help you find any mistakes that you may have made. Okay, being organized and being specific is really just a good habit for you as you move forward through all the rest of your math classes as well. Now, if I simplify, it all comes down to just being a over 2 quantity squared, because c over 2 minus c over 2 is 0. 0 squared is 0. There's nothing there that I need to add on then. And a plus b over 2 minus b over 2, they have a common denominator, so the b's would end up being subtracted out. And now, if I take the square root of that, I would have the length of RS is a over 2. The square root and the squared are inverse operations, so they cancel each other out. Now I do the length of OQ. So I take the coordinates of point O and point Q, and I plug them into the distance formula. Simplifying this, I would get the square root of a squared. And again, square root and a squared function are inverses of each other, so they cancel each other out. So the length of OQ is equal to A. So now we can say, okay, our conclusion, therefore, the length of RS is half the length of OQ. A over 2 is half of A. So we have now proven this triangle midsegment theorem. We did a different kind of proof, though. We didn't do a two-column proof. We did what's called a coordinate proof, where we use coordinate geometry, midpoints, distance formulas, slopes, writing equations of lines, all go into coordinate proofs, and it's a lot more algebra-based to prove something versus what we've done in the past with the triangle congruence proofs. So now we basically just have some problems that we have to be able to think through and answer to see if we really are grasping the midsegment theorem of a triangle. So here we have a triangle, EFG, and we're told that HJ and K are midpoints. Our job is to find the length of segments HJ, JK, and FG. So the key here is that we are given that these 3 points are midpoints. Because we are given that, we know we have midpoints all the way around. We can say, using that information, that segments HJ, JK, and KH are all midsegments. So we can use the triangle midsegment theorem. If we didn't know that, we couldn't use it. So we have to make sure we have the right information in order to use that. Oops. So we have, let's get rid of that. If we have this, and you can do any three of these first, it doesn't matter. Let's say I wanted to find the length of HJ first. Triangle midsegment theorem says HJ is half the length of EG. That's the side that it does not intersect. So EG I know is 100. The length of HJ would then be 50. If I'm going to find the length of JK next, JK is another one of those midsegments, so it is half the length of the third side, the one that it does not intersect, which is EF. EF is 60, so we could then say that the length of JK is 30. And then lastly, if we have to find the length of FG, notice FG is not one of the midsegments, it's one of the sides of the original triangle. The midsegment associated with FG, when we use the triangle midsegment theorem, is HK. Well, HK we know is 40. So this might be a time when you use the fact that the side of the original triangle is double the length of its midsegment. Plugging in 40 for the length of HK, we can say that the length of FG is 80. So that takes care of one part of the triangle midsegment theorem. Remember, the other part of the triangle midsegment theorem is that you have some parallel segments. So again, we have given to us the fact that we have some midpoints. A, B, and C are all midpoints of the sides of the triangle. So then we can say segment AB, segment BC, and segment CA are all midsegments, which means they would all be parallel to the third side of the triangle that they don't intersect. So in any order, we would have to say that segment AB is parallel to segment DF, segment BC is parallel to segment ED, and lastly, segment CA is parallel to segment FE. So here, we're told to find a specific angle measure, and then we're supposed to justify our answer, meaning give a reason why you are able to say your answer is what you say it is. So now, we don't have information given to us in the actual problem itself. The information is given to us in the diagram. So notice segment XU is congruent to segment UZ, segment YV is congruent to segment VZ. That means point U and point V are midpoints of their sides, so you could call segment UV a midsegment. And the key to this being a midsegment, why it's so important that we're able to notice that, is because, yeah, we could tell that UV is half the length of XY, but we're not talking about segment lengths, we're talking about angles. Angles with parallel lines, we've worked quite a bit with. Parallel lines come from that triangle midsegment theorem. So here, we're really not having to do any work. We would be able to say that angle VUZ is 65 degrees. What would be the reason that we would be using for that? We'd be able to say that the measure angle VUZ is 65 degrees because we know we have a midsegment, which means it's parallel to the third side of the triangle. We are using the corresponding angles postulate. All right, I have the diagram for number 8 covered up here, but I'd like you to see if you can do this one on your own, applying the triangle midsegment theorem, and enter your answers. So given the fact that we have the perimeter of the smaller interior triangle made up of the midsegments, we could find that missing midsegment length for NP, and then that would allow us to find the length of the three sides of the original triangle, two of which were the answers that we were asked to provide. So XY would be 28, YZ would be 44. In number 9, again, we're given X, Y, and Z are midpoints, so very important information there that we need to make sure we have so that we can actually work through this problem. Without it, we would not be able to do anything. So now that we know that those three are midpoints, we can say that X, Y, YZ, and ZX are all midsegments. So I'd like you to now find the value of X. So two ways that you could have found the value of X. The first way is using the straightforward equation from the triangle midsegment theorem and plugging in the expressions 3x plus 6 for xy and 2x plus 24 in for CB. So that would look like this. Now it just became an algebra problem. I distribute the 1/2 on the right side of the equation, move all variable terms to one side of the equation, all constants to the other, and then I just divide to finish it off, and I get x equals 3, and that's the correct answer. Now, the problem with this could potentially be that if I have to multiply by 1/2 and my values aren't even values, that could get kind of messy. I'd be dealing with fractions and decimals. So keep in mind, you have the other option of saying that the side of the original triangle is double the length of the midsegment. This way you're not multiplying by 1/2 at all, you're doubling things. Anything can be doubled. Might make it easier values to work with. So the work for that would look like the plugging in step, distributing the 2 this time, variables move to one side, constants to the other, and then dividing again to solve and find x equals 3. All right, our very last example. Using the information given to you in the diagram, what is the length of side AC in this triangle ABC? And then see if you can't give an explanation for your reasoning. In order to tell what the length of side AC is, we first have to focus on the triangle BGF that I have outlined in red. And notice that FD and DB are the same length, BE and EG are the same length, which means DE is a midsegment. So we'd first have to make the conclusion about the length of FG being double the length of DE, so this would be 8. Then we would be able to look at now the blue triangle, the entire triangle that I've now outlined in blue, and say that, okay, now we see that AF is the same length as FB, and BG is the same length as GC, so we now have FG being a midsegment of the large triangle ABC. So then we would be able to find out that the length of AC is 16, and then off to the right there, you kind of see what a written explanation might be for what I just explained verbally.